Hey guys, what we're going to talk about today is a little bit more evaluating expressions. However, the difference is this one is written as a fraction. Now, if you're looking for just simple evaluating expressions, I have another video on the channel that goes over exactly that. But this is kind of a weird case of an equation. You know, this is one of those kind of challenging problems you might see on that worksheet. And I want to address exactly what it means or what we do whenever we have something like this. Now, before we get to solve it, I want to talk about what it means to have this fraction bar. What does that represent as an operation in mathematics? Yeah, it represents division, right? So effectively, this could be written as the top part of the equation divided by the bottom half of the equation, 7 minus 20 divided by 5 plus 8. It could be written like that instead. But that gets kind of weird because we have a lot of parentheses in there, a lot of groups, right? So sometimes we would rather kind of abbreviate that really long equation or expression and write it as a fraction instead, because a fraction does the exact same thing that this would do for us. It separates the first half and the second half of the equation into two groups. Because take a look at this. If we wrote it as one big long thing, we have this set of parentheses saying, hey, focus on this and focus on that. But now, by separating it as that fraction, and let me get back to just this question, but now writing it like this, the problem kind of sets that up for us. It says, hey, you have that top part, and you have, hey, that bottom part too. So it separates those groups. And that's exactly how you want to think about it whenever solving one of these. You want to solve the numerator or the top part of the fraction. Solve that whole expression as one group. And then you want to solve the bottom half of the fraction or the denominator as another group. And you'll follow order of operations with each one, but you're going to solve them separately. So let's follow order of operations for this and actually put what I'm talking about into practice. When we look at our numerator, let me take these extra parentheses off there too, because they weren't there at the beginning of the problem. I was just adding them to explain that a little bit. We want to start with our order of operations, which as always I have written right over here. And we want to look at groups. Do we have any groups? Absolutely. Right here, parentheses, 3 minus 1. I'm going to use this little arrow to say my work is going off to the side here for the numerator. 3 minus 1, you guys know that, that's going to be 2, right? So really, we're looking at 4 times 2 plus 2. Next on our order of operations is exponents, radicals, none of that. Multiplication and division, we got that. Right here in the beginning, 4 times 2, well, that's going to be 8. And then we finish up with our very last part of solving, and that gives us a 10. Now, it's really easy to be like, I just did a math problem. I'm done. I finished. It's 10. That's the answer. But you always have to remember, that's the answer to the numerator. So whenever we get to the second step in our problem, you know, putting our numerator and denominator together, that is the top half, right? So I'm going to go ahead and write that down here. I'm going to make up an imaginary fraction here, put the numerator of 10, and then we'll figure out the denominator now. So order of operations tells us to look for groups. We don't have any, no parentheses here. Then we want to look for exponents or radicals. I still don't see any of those. So now we're at multiplication and division. Moving left to right, I first run into some division right here. 20 divided by 5, well, that's going to give me 4. So I'm going to simplify this. 7 minus 4 plus 8. Now that takes me to my final step in order of operations, addition and subtraction, which again works left to right. So 7 minus 4 is 3. Then we're left with 3 plus 8, and we get 11. So 11 is our denominator to this fraction. 10 over 11. That's going to be the answer. Now, if those could divide or simplify, then we would want to do that in this case. And if you have any questions about simplifying fractions, check out the video for that. There's one of those. I don't want to get this video bogged down with all that kind of stuff. But if this could simplify, we would. But since this is already in simplest form, we're golden. That's the answer we're looking for. If you have any questions about evaluating expressions when they're in the form of a fraction, drop them in the comments below. I'll get to it whenever I can. And otherwise, thanks for watching, guys. See you next time.